Hello everyone and welcome back to the Leetcode grind. Today we have 75 sort colors. It says here that given an array of nums with n objects colored red, white, or blue, represented at 0, 1, and 2, sort them in place so that objects of the same color are adjacent, with the colors in the order red, white, and blue. We will use the integers 0, 1, and 2 to represent the color red, white, and blue respectively. You must solve this problem without using the library sort function. So this is basically the Dutch national problem, where we have three partitions and we are to order them grouping the similar items. So let's say red is less, white is mid, greater than is blue. We're to group the similar colors together and in a certain order. And so we will be using this logic here, where basically, and we will go with a real example, but I represents the numbers that are less than mid, between I and j are equal to mid, between j and k are not sorted, and between k and the end is greater than mid. And I know that doesn't make a lot of sense now, but so j, remember once again, is the one that's not sorted, and k is essentially the right bound. And then if the number, and we're iterating our current unsorted number, and if that number is less than mid, or if that number is a 0, let's say, then we want it to be to the left of us. If that number was larger than the mid number, which we're using 1 for, then we want that number to the right of us. And if that number is 1 or the mid number, we don't do anything. We just move onwards because that is exactly what we want to do, which is that 1 should be the middle and everything less than 1, which is just 0 really, 0 should be to the left of us and 2's should be to the right of us. And to make this a bit clearer, let's actually run through a real example. This is actually a good input to work with, so let's use that. And we have our indices 0, 1, 2, 3, 4, 5. And remember, okay, so we have some index that we use to actually iterate this array. Let's say that it's cur, and we start from 0 and we process every number. So 0 until 5. And then we have some left bound, which again is 0. And again, once again, these are indices. And left will represent the next insert position of a 0. So as we're iterating using cur, if we ever find the 0, then we want to insert it into our next insertion position. And this will continue to increment by 1. Then on the other side, we have the right position where, let's say we're iterating using our cur pointer, and that cur happens to be a 2, then we want to insert this to the rightmost position, which is not 0, it's 5. So we want to insert, and once we do, once that position is filled, then we'll continue to decrement this guy. So let's actually run through an example. Okay, so we have the initial left and right bounds right here, and we're iterating using cur, let's say. And okay, well, let 2, I'm processing 2 right now. That's where I am currently. And 2 is a number that should be on the right side. So, all right, what's our next right position? It's here, great. So let's move 2 to here, take it 0, and fill 2. So these two are swapped. Once these are swapped, do you notice anything? Our right position is filled, so we can move down. Can we move this guy? This guy we cannot, because we know what we sent. We sent a 2 for sure, and that's the only we sent it to the right. And this is now 4. But we don't know what we received. So we don't do anything to our current position. We still need to process what we received. Okay, so now our current is still 0, left is still 0. It's a 0. 0 should be to the left of us, so our next insert position for the left is 0, and we essentially just swap. And then we can move both. We move both because our left is filled, so let's move the left. And we can move the curve because we did swap the two, so we know our current is done. Okay, now we're on indexes 1. And we once again have another 0, and we want to insert it into our next left position, which happens to be the same position. So we just swap in the same place. And once again, move both to the right. Okay? And now we hit another 2. Okay, 2 should be to the right of us. What's our next right insert position? It's an R. All right, so let's swap these two. I will take your 1 and I will send you my 2. So we know 2, this right is filled with the correct value. Do we know if our current value is so this is now 3. Do we know if the current value is filled? No, because we know what we sent, but we don't know what we received. So let's process it. It's a 1. And we're finally at a condition where we are exactly the value that we want to be, which is the value that partitions the left of 0 and the right of 2's. So this is great, and we move our current pointer only to 3. And then we say, okay, what's our current number? Our current number is 1. Once again, this is the correct midpoint that we want to be. We want zeros to our left, 2's to our right. We want to be a 1. That's great. And once we move through cur to 4, you notice that cur is now beyond right. And we know these are already processed. So we're done. We can't process anymore. We know these are processed here just by the fact that it hasn't moved. We know it's in the right place. And we are done. And so let's implement this logic like so. We started cur at 0. We had the left initialized to 0. This is the left insert position of zeros, which is the red. And we're incrementing. The right starts at the end of nums, and then we're decrementing, and this represents the next insert point of the next found 2. And then let's give it some more space here. Okay, and then you okay, and then what do we want to do? We want to say while cur does not pass r, so while cur is less than or equal to right, we're saying, first of all, if cur is 0, then, you know what? We want to be to the left. So we're going to swap the cur. Cur. Hold on. So let's do this way, where if the nums at cur is 0, then we want to swap nums at cur with whatever is at nums at left, because we want to send it to our left. And once we do, we know that left is in the correct spot, and cur can move on to the next spot. Let's give ourselves some space here. Okay, and then we say, all right, so that's if the current number that we're iterating is 0, and we want it to the left of us. So we swap it, we move both pointers. Now, if nums at cur is actually 2, then instead of left, we want to swap it with the right. So nums at cur with nums at right, maybe that's too big, I don't know, can be swapped to nums at right So we're swapping those positions, and remember, when we swap it with the right, we know what we're sending, so we can decrement right to say the next right insert position will be the one before it, but we don't know what we're receiving, so we don't increment curve. Okay, the final condition is if we're exactly where we want to be. We represent a 1. We're currently at a 1, and that's exactly what we want to keep it at. And we only want to move if the number is a 0. We want to move it to the left position, the next left insert position. And if it's 2, we want to move it to the next right insert position. So if it's a 1, we want to just say, that's great. That's exactly where we want to be. And I keep doing that. Just increment curve. And believe it or not, that's basically it. And that does represent this logic here for the Dutch national flag problem. And this logic that we went through. Let's see if we have any errors. Yes, we do. Line 19. Oh, you know what? We've used this. Let's get that out of the way. Okay. And yeah, there we have it. So, yay. Okay. So this was once again sort colors. Too big. Okay. Sort colors. Sort colors. Where essentially we are grouping into 3 different groups with a certain order, and we're swapping such that the 0, the red, goes to the left of our current iterating position. The white is our target middle, so we just move on. And then 2 is blue. And if the number is 2, then we swap it to the right boundary, the left and browns, and then the current. Thanks so much. Happy coding. See you next time.